Okay, Marin. So this is our little game, which is trying to challenge ourselves and thinking why we cannot deploy gitlab.com directly from master. So what are the blockers, and try to figure out if we are not doing this because we are used to not do this, or if so. Let's try doing this.
Sure. So my first question to you, as a immediate response to your question, is when you say deploy from master, do you mean deploying all of our components from master, GitLab Rails from master, or a specific component?
I'm thinking specifically at gitlab.com, so at GitLab Rails, because let's imagine that the other components are they're tracked there. So when something changes on Rails, I want to get it as soon as possible.
Let's use Rails as an example. Yeah. Couple of things worth mentioning there. Thing that comes to mind, number one, is the amount of commits that we have in master is overwhelming in general. Even like within an hour, you can just go and see how many commits there are. We do not have any sort of confidence that any of the commit that lands in master in its own is a stable candidate for deployment to any environment, let alone production. You also see that we have very frequent broken master situations, which means that any commit that lands after the one that is causing a problem is a potential problem because it might be hiding bigger issues because of the previous failure. So the volume itself is already creating a situation where you create a snapshot in time, and by the time you want to roll it out, you have a very big diff already to like get to the queue, right? Like that's one thing that comes to mind. Another thing that comes to mind is that testing cycle is extremely long, even if you just consider GitLab Rails. Paint a picture here. Merge request itself, all of the tests in the branch that need to happen run around for, I don't know, 80 minutes, and that is on average. So on average, we are around 80-minute mark, maybe 70. Doesn't really play a part here. This is branch. Now consider every merge request that goes into master is not going to be immediately green, because they'll need probably around an hour for each of them to actually pass. When that happens, we actually also need to create all of the artifacts to create a deployment. So it's not only building GitLab Rails container image, it is also all of the other components that are directly tied to the commit SHA here. So we will have to check out what is the Gitaly version, what is the registry version, and blah, 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 all of that, and build all of those from that specific SHA that is supported at that moment. That takes anything between half an hour in very good weather to 2 hours in bad weather. You already have like addition there of time that is very, very long. Now, once that is already, like all of that is done, you need to have a system in place that will be able to roll those changes out to a non-production cluster and then execute QA tasks on that. Let's say we are doing smoke tests and reliable tests. On average, they take around half an hour to an hour to complete before you can even progress to the next environment. If we are running the full test suite, it's going to be an hour and a half, 2 hours to complete. If you consider the timelines we are talking about here, and all of them sequential, exactly, you get half a day. That is our turnaround time. Our turnaround time means that if we roll out a specific commit to any of the environments and that breaks anywhere in the process, we have another half a day added to it to either revert the change, fix the change, or, well, no, revert the change, not even fix the change. Fix the change is like completely out of scope here, because fixing the change would add half a day more to the half a day, because you will have to, like, in the best possible situation, you will have to, if you have the fix immediately, wait for all of the tests and all of the pipelines to pass. So we are talking here about just the timelines that it takes for our systems to turn around things, and then add a human factor to it, right? If the human that needs to be resolving this issue is not there, they will take more time, right? If you need to find someone else to take over, more time to get familiar with it. So this is number 2. Number 3 is severity of breakage that can happen in master. Say we have S4s and S3s that we find in all of this process. Can we live with that passing further? Yes, in majority of the cases we can live with that. It's S3 and S4, minor inconvenience, there are workarounds, right? In those cases, we'll be fine. In cases where we have S2 and S1s, think of pipelines not working, think of project creation not working. Is the delay between commit being here, right? 10, 15 other, 20 other commits being added, and a revert here, plus the edit time. Is this an acceptable risk for us to accept that we will roll out 10, 15 other commits together with a revert? I don't think so, because in those 10, 15, 20, 100 other commits, you might have more S1s and S2s that you don't know about because of the broken thing that happened with the commit here. Those are the 3 biggest reasons, I would say, why we are not deploying for master. Now, there are workarounds with all of that, and I have that fully written out in the CD document I created last year. So we are slowly driving towards that, but that is the short answer on why, specifically from master of GitLab Rails, we cannot consider directly deploying to production or environments.
Okay, thank you, Marin. So I want to challenge this answer.
Please.
So maybe all of them is already written in the document, but just let's try.
Please.
So, volume of changes, first problem. This will not decrease, it will increase over time because we are hiring. So this can't be, per se, it can be a reason for not doing this, otherwise we will never. So I would just try to think about this. There's something about the volume of changes.
It's good now.
Yeah, the door was closing. So there's something about the volume of changes that it's interesting to me, and it's comparison between auto deploy and deploying from master. My point here is that we have no special guarantee that the point in time we pick for auto deploy is a point in time in master. So there's no real difference. So the only difference is how many time a week we are going to create auto deploy branch, because it's exactly the same. Pick the last green master and deploy and tag and deploy, or pick the last green master branch off, tag and deploy. It's the same story. So that's the thing. Build time.
Can I address the first one?
Oh yeah, sure.
As a response to what you just said, I fully agree with you. Absolutely agree with you there. And this is exactly why, like in the document I mentioned to you, I wrote that what we are doing right now and the path we are on right now is an intermediary step towards getting more discipline or getting quicker or more frequent snapshots, so to speak, right? Like instead of, like I said, like we were creating a branch once a week, now we are down to 2 times a week, right? And the end goal for this whole process is not to create branches, right? Like we are going to go down to once a day. But the end goal for here is to switch around things, and instead of creating branches, deploying directly from master. And when you notice a problem, being able to quickly branch out of that commit, have that be now your slower running branch while you recover the situation as quickly as possible, obviously, because you don't want this diff to grow. And then continue the process as you go further, right? Like you fixed the underlying problem there, you isolated the problem, you're not going to add any new things that are coming up. And then as soon as you're ready, you're going to pick the next one and then run that further. So that's the ultimate goal. Does that answer?
Yeah, it was the thing that I was trying to say right now, is that what prevents us from switching to this is just the human factor, because it's a matter of people knowing the process and being confident that this is how we work. Because
you know what's preventing us from this? From this step, the thing that prevents us from moving on it is we still have manual parts in the process. We cannot have any manual part in the process if we are to do this. If we want to go into this situation, we need to go away from continuous delivery to continuous deployment. Right now, we are doing continuous delivery. We are delivering software, right? In this case, because someone ultimately needs to be the one who is going to be clicking a button saying, can I deploy to production? Yes, you can. All right, I'm rolling this out to production. This cannot happen. We need to have the system, and this is the task that Yorick is working on next, that will ping the system itself, check exceptions, check the status of the, you know, all of our monitoring systems. Like, are we greenish to go? If we are, you're rolling things out automatically and informing after the fact. Once you have that system in place, how frequently you do this doesn't really matter. It is how quickly you can stop it and how quickly you can react to it, right? The discussion changes completely, right?
Yeah, and this moves us to the second point that we need to challenge, which is pipeline time and build time. I think that, yeah, testing takes a long time. We can work on this, quality can help, we can reduce this, but this is not the point. The point that I'm interested in too is the 2 hour for building a package. Now, the question here is, I don't know the details of
building an image.
Yeah, exactly.
Package is a bit different, yeah.
Yeah, but my question here is, I'm not extremely familiar with the details of how we build this, but what I'm thinking from the higher perspective, most of the time, commit is just several Ruby files that are the only thing that changes within the package. So all the dependencies are built from the same source code. Everything is just the same, just a delta of 10,000, I don't know, Ruby files. So are we using caching build server, or we just, so this 2 hours is
with cache?
Wow, there's no, what takes so long? Because this is a huge amount of time.
The unoptimized system that we have in place, it's what's taking so long. And the fact that even though the distribution is doing a great job in keeping this under control, no significant effort went into optimizing this further, because when all of these pipelines were built, we were aiming for good enough for the time. At that time, this turnaround time was outstanding. It took us less time to build the package than run the unit tests. Now we are changing the topic. The topic now is how quickly can we deploy, and that directly influences the build, is influenced by build times. So to give you a bit of perspective, Omnibus package itself takes around 25 to 30 minutes to build when the cache is warm. What does that mean? It means when only GitLab Rails has changed. Every other component that goes into GitLab Omnibus package is not being built at that time. When I say we, I mean distribution, optimize that process as much as possible. The additional 15 minutes on top of that package build time are fetching the cache, expanding the cache, building a new cache bundle, uploading the cache, doing some license checking, bunch of other accounting tasks.
Okay, but this should not prevent us from going further.
It is preventing us from going further.
It should not. I think it should not.
So not for auto deploy, not for gitlab.com, right? Because,
Yeah.
well, the answer is somewhere in between. For example, we are doing license checking at the moment where the package is built because of the way the systems are built there. It is important for us to abort immediately and very loudly and not deploy any library that has a license that is offending, right? Like we cannot deploy things that we don't agree with. And instead of, like we are doing it at the end of the pipeline, we should be doing it at the beginning of the pipeline. Various reasons why we cannot do that. A lot of it is because we use a lot of external dependencies.
Yeah, many of our components themselves have the same pipeline within the component. So this check was already run before.
Well, no, that's not really true, because you say a lot, I'm saying not everything. That is the big difference. So you have a couple of projects running this now, and there is an ongoing effort to make this true. But do you know how many libraries we pull from the internet that we build? It is unbelievable amount of gems of various libraries, dependencies of those libraries, and so on. Those are not centralized in individual projects. They are centralized in Omnibus when the build is happening.
Again, so the reason why one of those licenses may change is because of a merge request in Omnibus itself, not because of we upgraded our Rails code base or another one. So
again, not strictly true, because when a merge request in Rails updates a gem file, for example, it might be pulling a new gem with a new license, right? And it has maybe a native extension, and a native extension needs to be added in Omnibus, and that might actually fail. You know, like I understand what you're saying, and we should absolutely look into finding a way to optimize that. I'm just also saying that it's not as simple as, all right, we're just going to shift it left to a project and offload it there. There is a bit more nuance to it. Right. That is for the package. Let's go to the image. If you go to the image pipeline, we build everything in one, and a lot of things are cached. But the problem is the pipeline is not fairly optimized. The team hasn't focused on that. We kept the pipeline under a certain number that we thought was okay. Now, again, the discussion is changing. So we build, I think we cache Ruby image still, but it's a sequential sequence, right? Like you build the base image, then you build Ruby on top of base, then you build like a couple of others on top of this, and then you build workers on this. Like there is a lot of room there for improvement. And first of all, why are we building all of that in one pipeline is a great question, right? I know the answer to that, but I'm telling you, why are we doing that? Well, the reason why we are doing it is because we never went back to optimize that, because it was never important. It was good enough due to the turnaround time we have.
Okay, so sounds like that we could offload some of the check before, and there's a room for optimization, but is not a trivial task. Something that came to my mind is that if we know that building the image takes long time, and also all the license checking takes time, we can kind of build the package, trigger the next stage, and at the end of the next stage, which is prior to deploying, check back the status of the original Omnibus. So no, we have a halt signal here because the license is not good, but we can buy some time because we start doing. But yeah, this is just optimization. There's a lot of them. We can talk about it. So, but yeah, so I understood the point here. So, and I think that the severity of breakage is the same problem that we discussed on point one, because as soon as we can switch to a branched version and fix that, I think, so in my opinion, that one is not a real problem, because it's the same problem that we have to resolve first place in being able to deploy quicker, because the volume of change will not change. It will increase instead of decrease. So there would be more chance to find P1, S1. The more we code, the more bug we will put into it.
They're very much related. I consider them separate because they are actually separate problems to resolve. So for example, if a smoke tests fail, like in GitLab QA, something we depend on very heavily in our deployment pipeline, it is a stop the world situation, and that blocks everything else. So when you have a train, and then like one train stops and you have another coming up, you know what kind of mess is gonna be created. Like you're gonna have like a huge backlog, and cleaning that up is gonna take a lot of time. When I don't know how to put this nicely, but when the window is broken on a train, you're not gonna stop it. You're just gonna move maybe slower. So this is why the severity I kind of take as a separate thing, right? Like it's an S3, S4, okay, broken window, curtains are dirty, whatever, move on, you'll live. But if you see fire in one of them, you're absolutely gonna stop, and that is gonna have a huge effect on everything else you do. If you have a system where you can move the train from the track quickly, right? This is where we are talking about step number one, then they become very much related. But for me, like knowing when the train is on fire is a very important thing, and knowing how quickly we can move that train would be a problem on its own. So because like you're not going to be spending time putting out fire while the train is burning, your time is going to be spent evacuating people and moving the train off the track. So that's why it's a separate problem, right? The first problem is putting the fire out.
Yeah, I agree.
That's why I think they're a bit different.
Okay, so that's all. I mean, this is what I wanted to.
So according to you, what do you think, how much work all of this thing that we discussed is? How many people can we assign to this to actually only resolve this one problem?
The last one, or the
three of these.
Okay, all three of this. Okay, so I think the pipeline one is a big one. The other one are more. It's more a process problem. So there are consequences that are not really related to the tooling. Yeah, we have to update our tooling, but it's more about making sure that every bit of documentation is updated and everyone knows the process. And so the effort goes into different areas. But wow, how many people? More than what we have at the moment.
Yeah, so I can tell you, because I thought about this. One fully seated team of people who know the system is needed to only tackle these problems without a single other distraction from
like releasing every month,
like releasing, like like making sure, like all of that adds to distraction and actually delays things further. So if I got to like put like delivery team only on optimizing the pipelines, optimizing all of like the release pipelines and all of that stuff, without actually having you all to like manage the actual running process, right? Like create a system that will move the train and not operate the train at the same time, is minimum of one team, and probably over like the period of 6 months, just focusing on one of these 3 topics that we were talking about. Now I'm not saying that this is going to take like way longer. It doesn't have to, but to actually create a really good solution here, very effective, it's going to take a lot more focus. Iteration is going to take us a long way. So we will be able to do a lot of these things, but focused, it's going to definitely take less time than what we are doing, right? And that is, well, unfocused, well, so to speak. We are focused on other things rather. That might be a better.
Yeah, I kind of agree, because we have to build a lot of context in our mind because we have to think about the process from the beginning to the end.
To the end.
Every time you just go on, say, working on some fire with the train problem, so you kind of destroy all this context, and then you have to rebuild again and start thinking.
So I'm going to use an example here of when we set out to automate the deployment process on .com, right? The whole auto deploy thing. It did not even cross my mind that we will have to go very deep into how the deployment has been socialized with everyone else. Remember the type of problems that this exposed to the rest of the engineering and how it affected productivity. No one knew where things were when they were deployed because it was, you know, so those type of things that look small at the beginning but end up being like a big thing are things that are very big distractions, and you cannot not do them. That's the problem. You cannot avoid them.
Okay.
Cool. I'll
I'll say
stop the recording.